Hey there, welcome to this Vico Office demonstration video. Today we're going to share with you how to get more from your BIM. Sit back, relax, and I really hope you enjoy the video.
Vico Office is the first purpose-built construction management application to combine 2D drawings and 3D models to perform constructability analysis, location-based quantity takeoff, model-based estimating, model-based scheduling, and production control, all in an integrated workflow. Vico Office users are enhancing traditional processes and starting to exploit new BIM-based workflows to win new work and optimize their plan and execute more efficiently. We use the principle of leveraged integration to first plan and optimize, and then to track and control our construction projects. In about 30 minutes, this demo will orient us in the software, show us the importing of 2D drawings and 3D models, how we combine 2D and 3D and hybrid views, clash detection, change management, collaborative issue resolution, the importing of legacy data, manual and automatic quantity takeoff, project location management, visual BIM-based cost planning and exploring, BIM-based schedule planning and controlling, layout management and validation, enterprise reporting, and the Vico Office web server. Well, that's quite a bit to cover, so let's get started. Vico Office is a multi-user database solution licensed with single-user or shared server-based licensing plans. It has an extremely simple and very familiar user interface with 4 distinct areas. The first is the ribbon, which dynamically updates just to show us the buttons available for the active view. The second is the workflow panel, which walks us through the numbered steps in order to complete our specific virtual construction workflow. Clicking on a workflow item will open a view set. Each view set combines one or more windows of integrated 5D data. The palettes on the right-hand side allow for filtering of 3D views, adding 2D sections and elevations to 3D views, and editing of property data. Let's start with the document register. In the document register, we can create folders to store our project inputs. Here we're creating a folder called 2D drawings. We can now add some drawings by clicking on the folder and selecting Add Version. Supported file types are DWG, PDF, TIFF, and DWIF files. The first set of drawings, version 1, is now added to the Vico Office database. Clicking on a drawing and hitting the View Document button opens it for review. We can now add a second set of drawings with additional releases and revisions. For multi-page PDF and multi-layout DWG files, we can open and select the ones that we would like to import. This drawing set is now imported as version 2, and the automatic change detection engine flags with red squares any drawings that have changed. We can open a drawing and also simply drag and drop from the drawing list to view each of the drawings. Your team will have peace of mind knowing that they can have access to the latest design release, but always retain a full version history too. Let's check out bringing in 3D models. This is a Revit model. Simply hit Publish from the Vico add-on in the ribbon, and it will show you the available projects in the project server. Publish, and when your publish is complete, the model will appear in Vico's document register. Let's also publish the superstructure. Vico Office supports many different file formats, including Revit, ArchiCAD, Tekla, IFC, AutoCAD MEP, AutoCAD Architecture, SketchUp, CAD Duct, and many more. Here we'll see an architectural model being published from ArchiCAD as well. Importantly, Vico Office stores a full version history of the 3D models too. If we make changes to this Revit model, we can add some slab penetrations and modify some of the pile caps, remove some of the pile caps, and we can republish it as a new version of the 3D model. The new version will be flagged in the same way with a red square in our document register. We can then review the models and simply again drag and drop to see the latest version. Let's combine the 2D and 3D inputs to more quickly and visually clarify any scope gaps. We can add section and elevation planes, either horizontal or vertical or free planes, at any elevation. Here we're picking it from the 3D model. And then we can drag and drop any of the drawings from our document register onto that reference plane. The drawing won't be first aligned or scaled to the 3D model, so we simply select 2 points on the 2D drawing and 2 similar points on the 3D model to align, scale, rotate and make sure that that drawing is in the correct position. We can then use the drawing as a section box to check that the model geometry is complete and up to date with the contract drawings. We can also review missing information and account for that within the integrated 4D and 5D workflow. Let's check out clash detection. As we have the combined set of project models, we can quickly identify where elements are trying to occupy the same space. We first define what we wish to check by setting up rules, then run a clash detection and evaluate the results. Here we define the settings. We could run a layer-based or an element-based clash detection, selecting beams and columns and slabs for structural elements versus simply some equipment and ducts on the MEP side. We can then save the setting for future runs on new model versions and detect the clashes. The results are shown in Issue Manager, and we can filter by type. We can choose various modes to see these and review them by highlighting, isolating, showing translucency, auto reveal, auto zoom. The auto reveal mode will peel away any elements between you and the issue. It's important to note that these are object-to-object clashes. The system is not flagging multiple and unnecessary surface-to-surface clashes. After review, clashes that require tracking and resolving are promoted to the Issues tab. Let's filter for another clash and promote that too. We can then add clouds and redlining to the issues, mark priorities, define descriptions, owners, and really start to collaborate with the team to find a resolution. We find that our clients are really appreciating the integrated clash detection, issue management, RFI and tracking workflow combined with the full version history for all 2D and 3D inputs. Let's check out the automatic change detection engine for 2D and 3D inputs. Here we can see the slider mode with a different version of the same drawing on either side of the slider. We can quickly identify changes that haven't been clouded by the design team and add our own clouds that can be tracked in the integrated issue workflow. Quickly adding a note in the properties palette about these new stairs so that we can remind ourselves in our team meeting later. We can run a similar slider mode comparison for 2 versions of a 3D model, simply selecting the versions and comparing them and running the horizontal or vertical slider mode and seeing the changes between the two. When we switch to the highlight mode, we can see that the changes are color coded. Red for deleted, New elements are shown in green, modified elements in yellow, unchanged are shown in a transparent grey colour. Similar to the traditionally accepted 2D change management process, we can also add a cloud here to highlight any item that we would like to track and any pertinent changes that would need to be included in the estimate and schedule. Again, we can add a note in the Properties palette to remind us about the issue later. This integrated workflow allows us to compare any two versions of 2D or 3D design inputs, redline, assign, and track all changes for inclusion in time, cost, or other affected deliverables. Manually added issues and promoted clashes are reviewed together in a consolidated list. Opening an issue will display the 3D viewpoint from when it was created. The collaborative card view is great for meetings. It's a live report that includes a social discussion board to collect minutes from meetings, and this can all be reported out at the end of the meeting. As a team, we are now able to focus on issue resolution rather than the contractual and very admin-heavy RFI process. Any issues that cannot be resolved, however, can also be promoted through the RFI tab. The takeoff pad supports our existing traditional practice and still generally contracted use of 2D drawings. We use a manual takeoff process for any quantities that we don't have a decent quality 3D model for. We can also take off quantities from the 3D geometry, or even in this case, missing 3D geometry. Here we are taking quantities for wall panels for the 3 floors in these panes. These will be location-based quantities which will be available in our estimating and scheduling workflows. The same manual takeoff process can also be used in the 2D and 3D hybrid view. Let's turn on the cutting plane, zoom into an area, and start to add a manual takeoff process here too. Importantly, as the 2D drawings are scaled and placed in the correct building location, as I mentioned, this will be a location-based quantity takeoff. From the 3D building elements, we can calculate accurate quantities, not just rudimentary count, area, and length, but true construction caliber quantities that are valuable for estimators and schedulers. The vertical surface area, the top surface area, what about joint length? We activate a model to run these calculation rules. Selecting the properties we wish to group the takeoff items with and hitting activate will process the geometry, run the calculation algorithms, show the 3D model, and list the quantities. Selecting a takeoff item will highlight the elements that are being used in the calculation. We can also isolate an element type to identify the included scope. Opening a takeoff item reveals the calculated construction caliber quantities. Selecting a quantity like the top surface area or the edge surface area provides visual feedback on how they are being calculated. Here are some examples for the slab elements of the type of quantity that is calculated for you. Let's also activate the other models. We'll activate the superstructure model to see how the takeoff is automatically calculated for us, and then the exterior model. Note how the quantities from multiple model formats are consolidated into the same takeoff list. These element groupings and quantities can also be modified manually, either removing and regrouping elements or reclassifying takeoff surfaces by using the paintbrush tool. Here we have removed two elements from this takeoff item and are adding a new takeoff quantity for a specific surface finish along the edge of the pile caps. The consolidated model can also be investigated and checked for content and quality. Let's check out project location management. Vico Office uses a patented non-destructive element splitting technology. Here we see floor locations that could split, for example, columns that would pass through multiple floors. We see the floor isolated and understand what is included in that scope. Let's switch to the floor plan view for the foundations and add some zones for the concrete pours. We add polylines using the snapping features and leader lines. We'll divide the foundations into 4 pour zones. These 4 new pour zones will virtually split the elements in the foundation. It will also recalculate the quantities for each location. We see the 4 zones and the construction caliber quantities now divided into those zones. Quantities per location are the key to integrated virtual construction management. It's important to note that any historical investment in legacy systems is not lost. We start with many customers by importing their existing estimating standards and reference projects. It's a simple operation. We can select and copy the data and then paste it into Vico's conversion tool. We run the conversion and it will prepare the data ready to be imported into Vico Office. Inside of Vico Office, we select the view that we would like to import the data into. We select the file, and then we map the column headers, and selecting each header will import the required cells automatically. We've helped many companies transition without any risk from products like Timberline and MC² into this next generation estimating platform of Vico Office using Cost Planner. When all of the data is imported, we can see the exact same project estimate in Vico Office. Expanding the rows, selecting all of the line items and activating the assemblies to get the rolled up project total. We can now complement this estimate that was produced in a non-model based fashion with model based data. Using the Vico Customer Success Plan, we help companies set strategic targets for their first model based estimates. Usually the first model based estimate is actually only 10 or 20% model driven. These will develop over time with experience and also with better quality model inputs. We can also start an estimate from scratch using Cost Planner just like an Excel spreadsheet, manually inserting quantities, tabbing between cells and adding unit rates. We could drag and drop content from our standards or previous similar projects. And using the activation process, we can develop components and only include their numbers in the estimate when we're ready. The activation will replace the original assumption, it was 3.3 million, Now we're seeing it recalculated to be 3.24. Here we can show that same process by adding 3 components to the substructure. One for the piles, one for the pile caps, and another one for the slab on grade. We can use the formula in the source quantity cell to pull the quantity required from the consolidated list of quantities. We use the count for the piles, and at $1,000 a pile, we'll choose the cubic yards for the pile caps, selecting the net volume, and we'll select the square feet for the slab on grade. When we then activate this assembly, we will be replacing the $285,000 assumption previously made. We again see the visual feedback that the model provides. The elements will provide us with the geometry. The quantities are automatically calculated from the geometry and are then referenced into the cost plan. This connection means that any update in the quantities will automatically update the estimate. Let's delete the slab on grade line and drag and drop an assembly to replace it from our reference. We can see when we drag and drop that the quantities are automatically pulled from the slab on grade element. The activities underneath are automatically populated, and even the resource hours and costs are calculated. Behind Vico Office is an enterprise class database. However, the user sees a simple yet flexible spreadsheet type user interface. We should note that the assembly activation process supports a continually live but always evolving estimate. We can hit the button and release the cost at that point in time and have complete confidence in the numbers that we are sharing. As the design changes, we're required to quickly explain the effects. Here we can select 2 versions, the square being the older and the circle being the newer, and make a comparison to the target costs. The stoplight colors show a warning of at risk, over budget, and suspiciously low numbers. Selecting a node in the tree will filter all other views. We can quickly drill down to better understand the cost drivers and locate the elements and the cost line items causing the impact. We can see here that the external doors category seems suspiciously low, but clearly at 144% of the original budget, the external wall panels is the category at risk. We can select the older version and review it against the newer version to identify where the differences are. Quickly identifying in this case that it's a unit price increase. We could also see if it's a quantity change, productivity rate change, or a new number from a subcontractor. Vico's scheduling solution adds more power to the basic CPM scheduling method. Here we can see project locations on the left and time along the top. Lines then represent the flow of each trade as they move through the project locations. We can clearly see where people should be working and also where people are not working, the poorly utilized locations and the starts and stops. Schedule Planner can force continuous work for trades, and then after this, representing the waste, we can balance the resources so that we're using the optimum number of people on each trade. Buffers are then added between these trades to protect against any uncertainty in the workflow and make sure that the schedule is achievable. Here in the software we see a piling task added, which shows in the location-based view and also in the Gantt chart view on the right. By dragging and dropping from the estimate, we're going to leverage the integrated workflow and exploit any of the work already done by the estimator. The task is then loaded with quantities, costs, and resources for each location where there is work. We see more accurate scheduling because of the calculation for each duration in every location. Because of the varying quantity of work, we have a different duration. We can add more tasks, drag and drop, and define task drivers by adding the hours per unit or units per hour. This method results in task durations calculated for each location with the assumptions being made explicit and available for update. We can also have a many-to-one relationship, and if the estimator has already provided resources, we can synchronize using a one-to-one relationship between the estimate and the schedule. The next step is to define trade logic, and this can be done in any view, but quickly creating it in the network view and letting the layers of location-based logic automate the rest is a pretty fun way to build a schedule. Here we see how all of the trade links and logical dependencies are created automatically in the Gantt chart. We can now use the flowline view and drag the tops of the lines to see how many resources we would require in order to optimize around any of the bottleneck trades. 4 piling rigs here would be required in order to achieve the pace, 2 rebar crews, and so on. We can allow for some work like the concreting activity to be discontinuous, and we're dragging and optimizing the other trades around. We can highlight the critical path and then define the areas where we need to add buffers to protect against any uncertainty in the field. As changes are made in any of the views, all of the other views are kept in sync. Instantly, we can review the 4D simulation to check for any schedule busts. It must be noticed that this is not a new method. It was in fact used on the Empire State Building with amazing results. It was a 102-story building in 18 months, and they used the location-based management principles to plan for continuous and aligned work with the emphasis on controlling the work. They used actual quantities per location to plan. They managed by production rather than just by the end date. And they were trying really to reduce the risk of that cascading delay that we'll see later. This method was specifically designed for construction. We're able to highlight planned work by location, identify wasted opportunities, the bottlenecks and inefficiencies, the starts and stops. We're then able to optimize the plan and start with the right number of resources on the right date. We ensure continuous flow. And adding BIM and lean principles to this method just takes it the step further. We're really going to another level. We're being more efficient, we're being more accurate, and this collaborative scheduling method is really showing results. Most traditional scheduling tools focus on the planning and the recording of data, and less on the controlling processes required to actually execute to that plan. Using Schedule Planner and Production Controller with the BIM inputs, we're able to up our game. As we've seen, we prepare a more optimum plan by leveraging location-based quantities, productivity data, cost and resources to drive our schedules. We also use pull planning processes to implement realistic look-ahead plans and achieve commitment to the plan. Analysis of actual productivity data provides us forecasting and warnings of any potential clashes in the field, and we use these forecasts and the alarms to inform site meetings, implement mitigation measures, and really control the plan. We then complete that learning loop to provide better starting data and improve our next plan. In the tool, we use a simple matrix of locations and tasks to check off what's been complete. This progress is shown as a dotted line in the flow line. against the solid target lines. Green squares show complete, blue on time, yellow is behind, and red is late starting. The forecast is then shown as a dashed line in the flowline view. Alarm warnings with red dots forecast likely clashes, and the potential of a cascading delay is highlighted. We can see that the change of one drywalling crew is going to correct the forecast. Very simply, we had one crew. Changing to 2 crews will bring the drywalling back on track and correct the problem. In the software, we can step through time to today's report date by using the history mode. We see the dotted line showing historical progress for the piling activity. For the form pile caps task, we can enter progress by clicking on the matrix and choosing either simple start and end dates for that location, or by adding progress per day and indicating whether we were or were not working on some of the days. This productivity data will then be used in the forecast to show the impact of not changing anything over the next few weeks. We see the impact is a few weeks out due to this deviation in zone 3, but if we add actual resources used over the last few days and refresh the forecast, we can see the impact will actually be next week in zone 2. We can then edit the control plan to isolate the affected trades and evaluate what-if scenarios. We can see how changing working methods, working hours, overtime, or resources can mitigate the problems. In this example, we found that 4 crews were required in order to ensure that the trades did not clash. Through the implementation of these planning and controlling processes, our customers are able to make better informed decisions and clearly share scientifically driven and evidence-based data with project partners. To recap, we collect progress using the control matrix. Actual productivity and the remaining quantities of work will calculate a forecast. The forecasts are reviewed in the weekly subcontractor meetings. Control actions are discussed to mitigate potential problems and are used to make daily and weekly commitments. PPC metrics and root cause analysis are used to support a learning culture and help ensure teams work towards making more reliable promises. The social sharing process on site is done via the production wall. This is a visual display of progress, commitments, and performance. Let's see how we use Layout Manager to export layout points and then validate the position of installed work. Here we see an underground drainage run that could be affected if the pile caps were poured out of their design tolerance. We can filter for what we need to see and then play the 4D simulation to the point at which we are right now. We stop it at week 3, zoom into the area, create a folder for the pile cap points, and then we can add the points that we require to lay out in the field. Turning on the labels, rotating and viewing, maybe taking some screenshots to show in the field what we're actually laying out. We export the points, lay them out in the field, install the work. We must also complete the build to design validation process by taking the position of in-place work and importing the actual XYZ locations into Vico Office. After the import, any out of tolerance points will be flagged so that they can be investigated by the team. If this problem was noticed only after installing the pipe next to the incorrectly located pile caps, it could impact the location of slab penetrations, fixture positions, and even architectural wall layouts. This validation process, if implemented correctly, will provide an early warning system with the potential to save huge amounts of field rework, RFIs, and late reactive design changes. Moving to the reporting workflow, we can run any form of customized and parameter-driven reports, again to compare versions, create PDFs, and email that report to any decision makers. So instead of taking a roll of drawings, an Excel table with many tabs and summary pages, and a printed schedule with over 30 pages and 3 baselines just to explain a change to an owner, these collaborative Cost Explorer views and reports break down the barriers and allow the team to clearly communicate how these changes are impacting the budget. Through a web browser or a tablet, the Vico Office web server provides remote access to your project data. Logging into the web server shows firstly your project dashboard, and after opening a project, we can use any of the views that you have access to. Here we can see a read-only cost plan view with the 3D model on the right-hand side. As with Vico Office, you can select a line in the cost plan and you'll see the items highlight in the 3D model. The RFI view will show open RFIs, which the design team can modify, changing priorities or assignments or making comments. The Vico Office web server allows for the collection of data from project partners and subcontractors and sharing of views with the owner. Your senior management team could see dashboards with earned value status for all of their projects. The site team could use a tablet and add progress entry, and that progress entry is added directly to the Vico project server. The Vico Office web server also provides computer-to-computer connections, ODBC, SQL or XML service to other systems like project management functions and accounting. Our customers used to run between 5 and 15 different disparate tools working in many silos. Now they're able to increase automation and integrate almost every step of the process, allowing their construction experts to spend more time working with the customer on critical project issues. It's less time now measuring quantities, chasing details about a design issue, or manually creating thousands of estimating and scheduling line items. Right now is the time to pilot this integration on your project. Email us, set up a meeting with a Vico expert, and we can share with you how we engage with our customers, setting strategic BIM goals and achieving success on their first project.